All right. Hello, everyone. Thank you so much for coming here. It's 9 a.m. It's the second day of the conference, so you're already superheroes for being here. Thank you for choosing this room. My name is Maja Rydzy. I'm a full-stack developer. I work with Java, Kotlin, and Gosu. In the backend, in the front end, I work with React. No one here cares about my React. I know about that. The point is that I'm not a professional blockchain developer, so I'm not going to try to sell you any solution. I just experimented with it a little bit and decided to share the insights that I think might be useful for you. I'm super excited to be here. I don't live in Krakow anymore, but I grew up here and I spent a lot of time in this cinema, watching Lord of the Rings movies. There were these marathons that you can watch all night long. So I've done a couple of them here. It's super good to be back here. And the inspiration for this talk is the hobby that I picked during COVID. Other than Lord of the Rings, I like tinkering with stuff, and I started to make jewelry. I don't know if any of you picked any hobbies during COVID. I don't know if you still remember that there was a pandemic. There's so much going on. But yeah, I was trying to make jewelry. This is a workshop that I took classes in, but I'm not a craftsman. I was really bad at it. So I very quickly derailed into a side project. I wanted people who get my jewelry to have a digital proof of ownership. So I made a ring, one of the pieces that I made, and I gave it to my friend. And let's call my friend Frodo. And since it's a great ring, someone might want to steal it. I would like to have a system that keeps track of all the pieces I make, and you can easily find the owner. So, easy peasy. We assign unique ID to the ring. We have a user ID from some external account federation, use some OAuth, I don't know, Facebook, whatever, and we put it to a database. That's how we always do it, right? Frodo needs to somehow access it, right? He's not very technical. So that led me to the back end and to the front end. Okay, I do it every day in my work. So being enterprise developer, I defaulted to the stack that I was familiar with. You start with relational database. I just wanted it to be simple, couple of clicks, so okay, Amazon RDS. Then Spring Boot application, drop it on some hosted Kubernetes, not to worry about it. And then in the front end, I would start with like simple HTML, maybe then something more fancy, and just put it to S3 and host it. At that point, I realized that I'm not gonna finish in one afternoon. It's already more complicated than I wanted it to be. It is not only some development, but also maintenance and recurring costs. I just checked how much would it cost me. So micro instance in Ohio, that's the cheapest one I could find, $16. And then turns out the managed Kubernetes is weirdly expensive, so I just flipped it to EC2. This is just a side project. Then S3, okay, we could optimize it further. Let's say this is good enough. But this is still maintenance. This is still systems we have to work on. So this motivated me to look around more. And this is what this talk is about. Now, when I look at it, it looks like krakowskie obwarzanki, but this is my attempt to draw a chain, because we're going to be talking about blockchain. By the way, if you didn't try obwarzanki, if you're not from Krakow, these are these bagel-looking buns that you can buy from old ladies in Krakow. I really recommend you should try. But the point of this picture is that in the chain, there are rings, and each ring connects to the previous one. And it could be obwarzanki, it could be rings, but it could be also made of data. So in the blockchain, Each block of data contains the hash of the previous one, which connects the blocks. And I'm going to do a very high-level overview, just enough for this talk. Yes, it is a little bit more complicated, and there are different implementations, but this should be enough for this talk. The data itself is stored on the computers of anyone who joins the network. So if one of the users goes rogue and wants to tweak the data in an existing block, the hash wouldn't match. So it would be quickly detected. So it's pretty secure. And what people put in there? That's the most famous use. That's the ledger. And the ledger is a list of individual transactions. You put them by date, showing the amounts in every account. And this is actually, on this photo, is a booklet. I opened an account in the US, and they sent me a checkbook with something like this. So this is state-of-the-art 1920 ledger. You use it to track checks that you spend, you put the date, and then you know how much you have in your account. Bitcoin is almost that, just in a blockchain. But it's also possible to put their code. So some people put their other tokens. There are so many cryptocurrencies tokens that you use for payments. They put their games. They put their voting systems. And they put their anything else that you could code. A craze of 2021, I know, so last year, was non-fungible tokens. And it's a piece of code that a lot of people use to store pixel art or other images that sometimes would sell for millions. And you might laugh at it, or you might love it. I don't care. The truth is that the protocol that they used was pretty much what I wanted for my rings, for Frodo. So I decided to take a look. And today we're going to go through the protocols and through what is there. So while the concept of non-fungible tokens, it is quite universal. But the proposal itself was written for Ethereum, which is one of the blockchains. And Ethereum is using Solidity. So what you're seeing here is Solidity language. It is strictly typed, it is object-oriented, it runs on its own VM. Sounds very familiar, right? So lucky for us, a big chunk of its syntax is pretty intuitive to read for us, for Java developers. Let's see what they proposed. This is the interface from the initial proposal. The key function for me is this function owner-of. Each of my rings will have a unique ID. And this function allows me to find the owner. Unsigned int token ID, so the first ring I gave to Frodo, I would send their number 1, and I would get in return the address of the account from Frodo. Unless Frodo sells it, then I just know that I should hate him forever. Just kidding. The second function is actually supporting if Frodo wanted to sell it. So he can use this function to transfer the digital ownership. And this one has the first interesting concept because it has function modifiers. If you see these external payable, that means that you can send some money, cryptocurrency that is built into the blockchain, it's Ethereum in this case, while calling this function. Modifiers in Solidity can be used to change the behavior of the functions in a declarative way. So, for example, you can use your own modifier to do some checks before the function executes, if you want to verify something before your code runs. We're going to see some examples in the actual implementation. This is just the interface. All right. And let's jump to the implementation. So this is my blockchain-backed item. The smart contract that I will use to track rings that I make. The smart contract is like a piece of code that you deploy there. People say that one of the simplest and first smart contracts is a vending machine, because it's a state machine that always behaves the same way. Anyways, let's see. Let's see what we have here. First of all, if the proposal for this NFT token is ECR 721, and if you see these Open Zeppelin imports, I didn't reinvent the wheel. This is the library. If you code it in C++, do you remember standard template library? To me, this set looks very similar. It's just what people want to use. Someone already implemented it. So let's take a look. We have a mapping function here. There is a mapping of owners from unsigned end to address. So we send a token ID, unique token ID. We get the address of the account that owns it. This is the key for me, because I want to track the ownership of my rings. Other than that, there are like balances, token approvals. So if you want to give someone rights to work on it, but we're not going to go deep into this. The important function for us is owner of. So this is the function we would call to know who's the owner of the ring. If I want to buy it from Frodo, I want to verify that he's really the owner. So here I would send token number 1, and it would go to our map and simply look up the owner. Then it does checks. Require is very similar to assertion. Here it checks that the address is different than 0. 0 address is undefined address. Some tokens use it to burn tokens. So if you send something to address 00, it gets lost. So here we check that, hey, this is a real owner. This address exists. Otherwise, we throw an error. And we return the owner. So far, so good. And the second function we talked about is a safe transfer from. It does some checks and goes to transfer function. So here, we check that, first of all, you have to be the owner to be able to sell your token. You cannot send it to 0 address because my rings are too precious. And then we clear the approvals, because if you let someone else manage your tokens, well, that's no longer valid. And we reassign the mapping to the new owner. There are also events, but we're also not going to cover them today. Okay, so this is the ERC 721. There is one more interface that I use, which is Uri Storage, because these NFTs were primarily used to store pictures. And in my case, I want to put the design of my ring. What is interesting is that they usually don't store the picture itself in the blockchain. They store just URI to the picture. Like, what can go wrong, right? But I follow the same pattern that already exists. So people actually buy just URI, and this is hosted somewhere outside. They are finding solutions to make it immutable, but because storing stuff in the blockchain is not cheap, it's often just outside. And in the main class, I also added a couple of my own mappings. If Frodo loses the ring, we want to flag it. So then if the thief tries to sell it, the person who buys it will check, and whoa, this is flagged as lost or stolen. I don't want to buy it. And owner info, Frodo can put their contact address or something, or some award if anyone finds it. Okay, So far, so good. We have the high-level overview. So how do we actually create instances of these items after I make the ring? How do I track it online? We mint it. This is the function that creates a new instance. Here, again, we check that the address exists. We don't want to send it to 0 address. We make sure that the token doesn't exist already. It has to be a unique ID. And we send it to a new owner. Then we also set the URIs of my design. Does it mean that if I deploy this smart contract, any of you can just go and make your own rings and set the data there and like call my functions and just use it? Not exactly. There is a modifier. I really like these modifiers, so that's why I want to show it. So this is a modifier that comes from the library. The contract is ownable, and if you see only owner modifier, it checks that only owner of this smart contract can call mint function. So I'll be the only one who can create new instances. This is merge sign, so this suggests that this implies that we first do assertion and then call the actual functions. If we flipped it, the function would run first, and then we would do what is in the modifier. Right. So let's see if it's working. To test it, I used Hardhat. This is one of the test environments that there are. It allows you to emulate the blockchain. There also are some test networks for Ethereum, and we're going to try to deploy to an existing externally hosted blockchain. Although there is a lot of traffic there, so I know that presentations are cursed. Let's try it first on the hosted network. We're going to try the one that is called Robston. Okay. Okay. So, first of all, we need to compile our code. In this way, we're gonna, yes, this worked. In this way, we're gonna create what is called ABI, Application Binary Interface. Let me find it. I will make it bigger. It's just for navigation. Okay. So compilation generates the interface, and here we can see our functions owner of. It takes a token ID, which is unsigned end, and it returns the address. It's a view function, which means it doesn't modify the state. It is used only to see the state. This is very useful because if we call it from a node that has a copy of Ethereum, calling this function is going to be free, while the functions that modify the state will have to pay for. And one of the functions that would pay for is, for example, save transfer from, and it takes the address from, address to, and it's non-payable. This is the default modifier. That means that it might be used to modify the state. Okay. We compiled. Now let's do. And okay, this is the real function. I just created aliases not to type that much. So if you see this pretty magenta color, this is the actual function that is running. We are calling network, and we're trying to deploy it on Robston, which is a test network for Ethereum. And we're calling deploy BBI. Yeah, it worked. Deploy BBI is a script that I already prepared. But it's very simple. It just calls what the framework already gives us and waits for the contract to be deployed. Okay. Now I'll go to the kind of a browser of Robson network here. We should already be able to see our contract that got deployed. Oh, no matching. Sometimes it takes some time. I'm in the right network. Sometimes it's pending, so I prepared one before this presentation. You can see 16 hours ago I was testing it. And I did one more thing, because even if the contract just gets deployed, you can also verify it with Etherscan, and I already did it. What it gives us is pretty cool, because here, this is the code that we were just talking about. And because of that, we can call all these functions directly from the browser. So we can see what is happening. For example, let's mint a new item. Oh. I already created a script that can mint the new ring, and it's gonna be. So let me just call it mint. Okay, let's see if this transaction cleared. It's still pending. So we can see that it is, they are working on it. The blocks are created every couple of minutes. So it will happen eventually. In the meantime, last night I prepared some. So let's just see. Owner info for token number 1. Wait, not owner info, owner off, token off. And this is the address of the account that I used. This is all test accounts. So you can create as many as you want, and you can you can use, how do you call them? Anyways, there are websites where you can just request the free Ethereum for your test network, so that you don't spend actual money. Like seven coins, it is like $14,000 at the moment, so I wouldn't waste it. But this one is a test network. For viewing, we didn't need to authenticate. If we want to write something like set lost or stolen, we will have to authenticate and actually spend some money, because this is going to change the state of the blockchain. So I'm connecting here to my MetaMask. We can also do it from the command line, but this is a nice way to do it. Let me say I will set the token ID number 2 to lost or stolen. All right, and it tells me how much it's going to cost me. This wallet has a built-in system for guessing what I should offer to pay. We're going to talk about it in a moment, but basically there is a base fee you have to pay, but you're also in a bidding war with other people who are trying to write to the blockchain. So you can say, I'm willing to pay more to have my transaction clear faster. which is pretty funny in a test network because we're in the bidding war of free tokens, so it can go to infinity. Let me confirm that. Oh, underpriced. I offered too little, apparently. It changes pretty fast. Let me try again. If the network is busy, it's sometimes really difficult to get your transaction cleared. Okay. Let me try what it suggests again, not override it. No, still underpriced. So if someone is bidding really, really hard on it and paying way more Ether than it is needed. Okay, let me. Okay. So to sum it up, blockchain back item is the smart contract, which is basically like a class, and it stores a couple of maps. We have a map of owners. We have a map of token URIs. And that's how we track who owns which item. So Ethereum is like a state machine. And activities such as transactions, such as minting, they continuously modify the state. But once transaction is sealed, it is forever to be there. So there are like two trees that they keep. One of them is immutable. This is all the transactions that are saved there. And the second one is a state which tracks current state to be easier accessible. Okay. Oh, sorry about it. And the fees. So what we saw a little bit right here. Base transaction fee gets burned, and a tip goes to the nodes that maintain the network. So if you're maintaining the network, you're getting something out of it. All these people that are mining. And the gas limit is the maximum amount you want to pay. You need at least 21,000 GUI, we're going to talk about it, for a simple transaction. And this GUI is 1 billionth part of Ethereum, because fees are way lower than the main currency. They're using this different unit. Every block has a base fee, the minimum price per unit of gas for inclusion in the block. So you can bid, and then if you bid too low, you will just never be picked by the nodes that are working, because everyone wants to get the highest tip. Also, if you set your gas limit too low, it will start executing. It doesn't verify it up front. So it will start executing, and then you will run out of gas. You will lose your gas because the work has been already done, but the transaction itself is going to be reverted. So you have to be really careful coming up with these numbers. The wallets like MetaMask have it built in. So if you go with whatever they suggest, you will not run out of gas, but you might wait. All right, so this was Ethereum. This was one of the options. But looking farther, I didn't like how centralized it was and how slow it is, and there are some disadvantages, right? So I looked at other blockchains, and the one that caught my attention is Flow. It was built specifically for NFTs. I know, someone built a blockchain just for NFTs. And the programming language is Cadence. It is slightly different. It's using proof of stake instead of proof of work. Ethereum is trying to move to it, which means proof of work is this super computational heavy way of proving that you're doing your part in order to get tips from the transactions. Proof of stake, the idea is that instead of spending money on graphic cards and on CPU, you spend it on the coins, and the computations are simpler. But the person who has the most coins in stake gets the most award. And it's designed to support games and consumer applications. So it has a couple of super interesting concepts. So I really was really happy to see that it has resources built in the language. And a resource object cannot go out of scope, it cannot be go lost. There are types that can only exist in one location at a time and must be used exactly once. So they kind of want to represent one non-fungible item. And the end of function, which has resources in scope, the resources must be either moved or destroyed. They cannot just get lost. They have implicit field, which is owner of the resource. So for me, that was really convenient because I could use this field to track the ownership. If Frodo gets the resource that represents my ring, we can find the owner. The second thing that I found super useful is access control that was built in language. So in Ethereum, in Solidity, we had to use these libraries to get access control. Here it is built in. So you get a public or access all, which is read from outside but no write. And you can have also access on contract level, on account level, and this is built in the language. Okay. Let me open the code. There you go. Again, blockchain-backed item, but a different blockchain. And let's see how the implementation differs. We have a non-fungible token, which is their sample implementation of it. They already want to redo it, but this is the existing one. And we have, if we go here, it has an NFT resource. The NFT resource has ID, so this is my rank number 1. We put their name, description, we can put their picture or whatever we want, and my flags is lost or stolen, an owner message. These ones are constants. This one is going to be modifiable by the owners. If someone, the owner should be able to say, hey, I lost it, don't buy it from the thief. All right. And the collections are what we're interested in. In order to give others access to any resources, we have to give them the access to the collections. Sorry. Is that okay? I think so. So there is like public collection. Oh. Okay. Oh, dziękuję. Dzięki. Thank you. Thank you for your patience. A little technical break. Public collection. So this is something that we're going to store in our public resources so everyone can deposit stuff to our account, because I don't mind getting gifts. Anyone can see them, so they can borrow the instance just to see it. But then we have another collection, which is going to be admin one. And I don't want everyone to have access to set lost of stolen or stolen functions, set found, or set owner message. This is just for the owner of the contract only. Right. And in order to create that, we again create a minter resource, which initializes a new item. So we set the name, description, when we create it, it's not lost or stolen, and we give the owner message. So this is initialization. We put the public collection into our, we link it to our public folder. That means everyone is going to be able to see it. But then the minter, we just keep in our own storage. It's only us who's going to be able to see it. And if we go here, there is a flow emulator. This time I will just do it on the emulator instead of trying to do it on the test network. I'm not going to risk it. Okay, let me run the emulator. I just started a clear emulator, so I will have to deploy all my contracts. And again, this is my alias, so look at the pretty magenta code. That is the actual function that is being called. So in my account, I already configured the emulator account, the default one, and I deployed there the base non-fungible token contract, as well as the view contracts. It didn't get highlighted that nicely, but it's here. Metadata view, which allows us, which is just interfaces for viewing, and our blockchain-backed item, that's the contract we were talking about. The other ones were just dependencies. So once we have it deployed, we can mint. And here is what is interesting. So we first have to build a transaction. And as we said, minting is for the owner only. So it has to be a signed transaction with my private key that I configured in my settings. I have to prove that I'm the owner of this contract. So first, I'm building a transaction. This is my account number. These are the arguments that are already preset. So I'm saying that recipient is myself, name is this, description, GeeCON ring, and the message is going to be GeeCON 2022. And this is the code of the transaction that I'm executing. So that's a boilerplate code to basically build the build our transaction for minting our NFT. And it asks me, are you sure you want it? Yes, very confident. Now I can do flow. Now I have to sign it. Again, it asks me the same transaction, but are you sure that you want to sign it? Are you sure? I put my emulator account that I pre-configured. Are you sure that I want to confirm that this is what is to be executed? Yes. Flow. And finally, I can send a transaction that is already signed. So here is the command. This is the file I saved it to, include the payload, send signed, yes. And success, we got it. If I want to see it, then the view scripts, as we said, we don't need to sign. Anyone can see what tokens I have. So here I executed this. Oh, is it too small for you guys? I'm just realized. Yeah, okay, thank you. Get metadata. So here we basically just read the collection. We know the address. I sent my own address. We borrow the capability to collection, and we build the NFT because we have the read rights. We couldn't mint, but without any approvals, we are able to initialize that and see our result. So I'm the owner. It's not lost nor stolen. The name is BBI for ring. It's GeeCON ring. So this is what we just created. Okay. This was a really quick overview, but I just wanted to show you the most interesting for me concepts. Now let's take a step back. In the Ethereum, we had map of owners and tokens that lives in a contract, right? It's very centralized. Then there are issues with that. In Flow, the access model is already there. We use resources that are stored within the accounts that own it. So it sounds like more scalable architecture. We have a smart contract that just interacts with it. But if I find the ring on the beach and it's of ID 1 in Flow, how can I find the owner? With the approach that we took in Ethereum, this is easy. We go to the map of owners, we look up token number 1, and we get the owner's account. In Flow, well, the resource lives in the account, so there is no central map that maps the other direction. Of course, we could add it to a smart contract, but that's against all this idea of having resources living in the account. So the right solution there is actually create an event, send it to an external application, host a database that stores the mapping for you, and probably even build a front end to interact with this. So with this, I found it a very optimistic conclusion, because even if Web 3.0 goes crazy and picks up, it seems like us, Web 2.0 developers, will still have a job for a really, really long time. Thank you. Okay, let me check if there are any questions. Here we go. Isn't it a problem that if someone stole a ring and tried to sell it, its token probably wouldn't be ever checked in a real-life scenario? Absolutely, yes. Yes, it would be. So it is, as with every system, even with security, the problem is the process and people. So I'm not saying that I solved the, I found a solution for all the robberies in the world. However, I can totally see that for high quality items that are really expensive, I would check it before buying it if I was a geek who's looking for this particular item. But that's definitely true. How is the code you've shown protected? What happens if you have bug in the code? That's a very good question. So that's why you really want to test well. Because in the basic implementation, once you write it, it's out there and you can't modify it. There are some hacks that people put into place to be able to, you point to the address where you can swap the contract to overcome it. But the idea is that the code is source of truth, and when it's there, it's there. Like in Ethereum, there was this case that they had a bug, and there was a big deal because it was a bug, so someone was able to steal a lot of coins. But there was a lot of people who claimed, well, source code is the truth. If the source code allowed it, that's how it's supposed to be. So the community was split on that. But basically, it is, you have to test it really well. Can I deploy the ERC contract on other blockchains such as Luna? I believe so, but to be honest, I never tried it, so I can't respond to this one. Do we still have time? Okay, maybe. It looks like despite using blockchain, we still need the infrastructure to be there. For URIs, absolutely. I wonder what we actually gained here by using the blockchain. Yes, I found it very funny when I first time long ago realized that, yes, they are just storing URIs. There are some blockchains now that are trying to make storage cheaper. And when the storage is cheaper, you can actually put the pictures or whatever you want in there. Ethereum got really expensive. So that was the main blocker. And then people tried to make like blockchain-like services where you can store these pictures so that the URI is guaranteed, but nothing is guaranteed. Unless you put it in the blockchain. In the blockchain, however, like if you put smart contracts, they are already there. They are going to be there for good. So if you can afford putting it in the blockchain, it should stay there immutable as long as the blockchain exists. Because if there are no miners, the blockchain is going to disappear. What are the most popular programming languages used with blockchain technology? So I believe I picked where there are the three main ones. But OK, there is a lot of them. Ethereum, I think, is the biggest one currently for smart contracts, so Solidity. We looked at Flow blockchain and Cadence, and this is just picking up. And there is also Cardano blockchain that is gaining some traction, but also there is a new project every week. So it's sometimes difficult to keep track of the languages. Right. Any tips on how to start learning blockchain as a Java developer? I found it pretty straightforward, especially with Solidity and with Ethereum. Yes, Solidity for Java developers, that's why I picked this as a topic, because I was surprised how easy it was. So I think just go through the tutorials. There is a lot of good tutorials for Solidity, and you will be good to get started. Can you please show GitHub link again? Absolutely. I think the slides are going to be published somewhere, so that should be there. And these are like fun projects. So I didn't set up entire infrastructure, testing, et cetera, et cetera. It's just a fun presentation project, not a production-ready deployment. But I think it's good enough to get started. Can we predict via Java or Python code the Bitcoin prices or currency in general for at least 1 week? Well, yeah, I mean, you can go into, but that's more like investing question. There are these people who claim they can do it, but I think they would be really rich by now if they could. So I don't know the way. You can certainly try. Yeah, and for decentralized storage, yes. Thank you for that. Absolutely. This is one of the places where people put the decentralized storage. So whoever put it, thank you. Yes. All right. We're right on time. Thank you so much for coming here, and have a great day.